Then asked you again, what are isotopes? That's your definition. Define radioactivity, define radioisotope. That should all be fine. Carbon 14. Remember the atomic number of carbon is 6. Beta again, so 0 minus 1. So you'll see there nothing happens to the mass number. Atomic number increases by 1 because you're gaining a proton. And then look up what is an atomic number of 7, and it's nitrogen. Then it tells you there that the world's oldest shoe was found in a cave, okay? And it told you that it was 5,500 years old, whatever. Then it says explains why the carbon 12 to carbon 14 ratio has changed. Now, nothing happens the amount of carbon 12. That stays the same because carbon 12 is not radioactive. So after the organism dies, the level of carbon 12 remains constant. But what happens this is the level of carbon 14 drops. Because carbon 14 is radioactive, it decays to nitrogen. Look at it up here. That's what happens, carbon 14. It changes to nitrogen. And therefore, when you look at the amount of carbon 14 that's dropped compared to carbon 12, and you take into account the half-life of carbon 14, you can age the artifact. You can see how long it's dead for. Okay, question 8 then. Again, defining radioactivity, defining half-life, that should be fine. And then it asks you, so it gives you Americanum 241. And then it asks you to identify A and Z. And you know that it's alpha emission because you can see here. So all you have to do there, look, is subtract 4 from the 241. And when you do, you'll get A equals 237 and 93. That should be fine. And then one risk associated with exposure to alpha, well, causing mutations, okay, causing cancer. Now, it can't penetrate your skin, but you can inhale it. So if you're exposed to alpha particles, it goes down into your lungs, causes lung cancer, okay? Why, if you've got a smoke detector in your house, are you not at risk? Because it's not penetrating through your skin, okay? So something like that it's not, what else could you say there? That it's not penetrating is the word you're going to use, okay? There, like that, okay? And then the other thing they asked you there then was why you don't have to change them regularly, because the half-life is 432 years. So, you know, it's going to certainly, half of the sample will still remain after 432 years. So it doesn't need to be changed like batteries. 2 properties of alpha. Now remember that alpha are positively charged. They're attracted to the negative. They something like that. Don't say that there are 2 protons and two neutrons though. We went through the differences between nuclear and chemical reactions already. And then finally, the 3 types of radiation in order of increasing penetrating power. So you'll say alpha, beta, and then gamma. Okay, thanks.